In this video, I will demonstrate how to perform the ANOVA-Two-Factor with Replication Tool. What this tool does is test for differences between the means of two or more dependent groups or sets of scores. This is also referred to as a mixed design ANOVA, or a split plot ANOVA, or a between within factors ANOVA. So what's happening here is we have two different types of activity levels of groups of patients, so a high activity level or a low activity level, and then the patients are going to receive two different treatments, and then we're going to measure their depression level on a scale of 0 to 10, with 10 being highest level of depression and 0 being no level of depression. So the subjects are going to receive both treatments, so this is referred to as a crossover design, so it's the same subjects receiving both treatments. So because all the subjects are receiving both treatments, this would be considered a repeated measures or a replication type design. These two columns could also represent two time points, kind of a pre-test, post-test design. So this type of ANOVA allows you a lot of flexibility as far as how you're going to design your experiment. But in this case, we've got subjects receiving two different treatments, and they're being placed in two different groups. So the activity level will be considered the between groups factor, and the treatments would be considered the within groups factor. So what we're going to try and determine is, does activity level by itself have an effect on depression level? Does type of treatment have an effect by itself on activity level or on depression level? And then also to see if there's a unique interaction between the treatment and then the activity levels of the patients. So in order to do this analysis, we're going to go to the Data tab and then click on the Data Analysis option. And we're going to find the ANOVA Two-Factor with Replication option. Click OK. So our first step is to highlight the data areas. And so we want to highlight the areas that include the data as well as the row and the column labels. So we've got labels for the rows here on the left-hand side, and then we've got labels for the columns. So we want to make sure we include the labels for both of those. And we click the Ref Edit button. And then we need to then tell Excel how many rows are in each sample. So in this case, we have 6 rows in each sample for a total of 12 rows. So we've got 6 rows per sample. We're going to test the hypothesis that there is no effect of activity level or treatment on depression level at the p less than 0.05 level. So we want to make sure that's indicated. Then we need to indicate the output range. So we want to click the Ref Edit button and make sure we're highlighting the area where we want the output table to be placed. And then we click the Ref Edit button again, and then we're ready to go. We click OK. Now what we're going to see here are several tables that are arranged for us, and it can look a little confusing at times. But what we'll see here in the columns are the means for each of our two column sets of data. So the two different treatments for a high group and then the low group. So the rows are represented in each of these tables, and then the columns are represented within each of these tables. So if we look closely, we can see for the group that had a high activity level to begin with, there really doesn't appear to be much of a difference between the new treatment and the traditional treatment. For the people that had a low activity level, again, we don't see a whole lot of difference between new treatment and traditional treatment. Now, if we look at high versus low, using new and traditional treatment, we can see there are some differences between the means between the high activity group and the low activity group. So for new treatment individuals, there's an average of 4.3 for high activity, and then for low activity it's 5.8. And then for high activity using the traditional treatment, their score is 4.6, and then for the low group it's 6.3. So let's see if there is a statistically significant difference among these sets of means. So the first row we can look at is the sample row, and this refers to the difference between the groups that are in the high activity level versus low activity level, regardless of what treatment they received. So we're just looking at the main effect now of activity level. And here's the F-score of 17.87, and here's the p-value, and this is much less than 0.05. So it appears that activity level has a significant effect on depression level, regardless of the treatment they received. Now we look at the columns, and again this is comparing new treatment to traditional treatment regardless of what their activity level may have been. And we can see the F-score is 1.23 and this p-value is greater than 0.05. So treatment by itself had no effect on depression level, again regardless of what the activity level was. So treatment by itself, regardless of activity level, had no effect. And the last thing we can look at is the interaction. And again, we have a very small F value and we have a large p-value, again greater than 0.05. So there is no unique interaction between different combinations of treatment and activity level. So again, to summarize here, what we can say is that activity level had a significant effect by itself on depression level. Treatment, new versus traditional, had no effect on depression level by itself. And there was no unique interaction between these two factors of treatment and activity level. So hopefully you've learned something in this video, and good luck using this technique on your own.